Okay, so these are the ones we've been working on. You're familiar, you know what these acronyms stand for. Like, how, Taya, how do I say this actually? It's not sin, what is it? Sine. And Cannon, what's this one? Olivia again. Okay, so we've learned a lot. I don't know that you've seen a ton of those before. So the mathematicians wanted to do these inverse operations. So I don't like it written like a slant. Do you see that it's, in fact, I'll fix these. Opposite over hypotenuse. Some ornery horses. It's flipping it. Can't always have. It's flipping it. Tons of apples. It's flipping it. So will you write them down like this? And you don't do the slant fractions. That is so confusing. So make sure you write them just directly on top of each other, because you're going to want this for your homework and you're going to want this for the assessment. I'll probably put it on the board. Oh, more trig. It's just called more trig. We don't do much. You don't. So this one's called cosecant. So that's how you say this, cosecant. This one's just secant. Any guesses on that one? What? Cotangent. And they're just upside down. They're the reciprocal with their own fancy name. Make sure you write down how to say them. I hate when you say caught. Write these down. What is that? An Amber Alert? You're forgiven. Okay, while you guys are finishing that, I'm going to write them over here on the board, because we are not going to want to be flipping around on our notes every 5 seconds. Oh, I'm afraid I'm going to have to erase some of this. Sorry. Oh, it's been on here so long. Sorry, I'm carrying way too much stuff. So cosecant is the opposite of this one. Secant and cotangent. All right, now I won't have to keep referencing back to stuff. So you don't have to write this in your notes. We're going to just do this together. And I will start with, I've already picked on you. Damon, what numbers would go for sine of A? Whoa. Why did it do that? Yes. Opposite over hypotenuse. Ruby, how about cosine of A? Adjacent hypotenuse. Already picked on Sam. Brenda, tangent of A. Okay, so tangent is opposite over adjacent. So looking at angle A, which number is opposite? Four? Mm-hmm. Which one's adjacent? Yes. It might help if we labeled these, right? So are they all angle A? Yes. So this is our hypotenuse. This is adjacent. This one's opposite. That'll make it easier. Then we don't have to keep looking and referring. Okay, Isaac, what is the cosecant of A?
Let me look.
I have it on the board too. So it's taking whatever the... Over what? It should be the opposite of this one.
Oh, over opposite, yeah. It's that side.
Cotangent. I'm making sure I did that right.
My O looks like an A.
Okay. And Claire, what is secant of A? Yes. So you may have noticed that one's the reciprocal of that one. And Edwin, what's the cotangent of A? Okay, so cotangent is adjacent over opposite. So we've labeled them. Which one's the adjacent side? Well, we labeled it adjacent. So the 3. Which one's opposite? Not sure. That's okay. Shaylee, which one's opposite side? Okay, and you may or may not have noticed that these ones are reciprocals of each other. So the ones we're familiar with, if you find it and then you flip it. Sometimes I find it, flip it, because we're super familiar with these. Oh, heavens, we're not doing 10 more. Okay, write this one down. We're going to do a couple examples on how we use these inverse ones. So write down, given cotangent theta equals 12 over 5, find secant theta. If you want to work ahead a little bit, the first thing we do is draw ourselves a generic right triangle, label theta, so we're given this information. The cotangent of theta is 12 over 5. So I don't know, I always do mine like this, and I always label theta as the top left. I was working with Mr. Hogan. He always makes the bottom right one theta, so I don't know why. So I'm going to look over here. Cotangent is adjacent over opposite. So I can use that information to label my triangle. My adjacent side is here. My opposite side is here. So far all we've done is write down the problem. Looking at our formulas, we've distinguished what these are, what are we being given, and put them on the picture. Keegan, what do we need for secant? What are the two sides that we need? We've got adjacent, it's the 12. So we've got the 12. How do we find the hypotenuse? Lauren, what would you do to find that hypotenuse? Say it again? Yeah, we don't know any angles. We can't use our trig functions. We have to use Pythagorean theorem. I believe this one is a Pythagorean triple, but we will set it up anyway. So 5 squared plus 12 squared, I think it's 13. I guess we'll find out in a minute. Is it? There's a few Pythagorean triples that we have seen a lot. And so some of you will start recognizing them and memorizing them. So 25 plus 144. Hopefully you're working ahead of me a little bit. Okay, once we do the Pythagorean theorem and we have the hypotenuse, that's the answer that we're looking for. The cosecant of theta is 13 over 12. What do you think of it? What do you think of this? You don't what? You don't need it? You know, I wasn't the mathematician that came up with it or found the value in it. I do know, though, for those of you who are going up into the higher levels of math, you will need it for that. You definitely will need it for that. And if you're going to calculus, you'll need it. If you're going into math 3 next year, you'll need it. So that's your immediate, like, I know it's not your profession, but it's kind of what you do. So this is to build our brain, memorization, labeling things, seeing patterns. That's a lot of what math is. Not everything is like in my profession as a engineer, I'm going to be doing this necessarily, or whatever you want to be. But it's more this, by memorizing, finding patterns, labeling things, that's building your brain. It's like going to the gym for your arms or running on the track. But it's, so think of it as exercise sometimes. Like as an adult, when are you ever going to jump hurdles? Or do javelin or swim an hour and a half, right? So there's a lot of things you're doing that aren't like, I'm going to do this for my job when I'm older. But we do it to build our bodies, to build friendships, social ties, to make our brain stronger. So that's how I think of it. Okay, let's try another one. So I'm going nice and slow because that's kind of what you have to do on these. With all these same letters everywhere, and just keep this handy. If you can have this at the top of your page, you don't have to memorize it. You just have to look back and see which ones we're using. So write it down. Given cosecant equals 4, find tangent theta. So first thing I would do is draw myself a reference triangle. Look back here, see what the cosecant parts are. What are they giving us? Put them on your picture. So I'm seeing, I'm going to put that over 1. Cosecant is hypotenuse over opposite. So I already know some of it. To label your picture, the hypotenuse is 4. The side opposite of our theta is 1. Sophie Jensen, how do I find my missing side? Yeah. So the side opposite is the one that's a 1. The hypotenuse is a 4. So be careful on this. It's not a squared plus b squared equals c squared, and we're finding c. It's a squared plus b squared equals c squared, and we're finding b. So I don't actually know the answer to this. We're going to be doing what? So what's the square root of 15? 3.9? Oh, we're gonna. 3.9. Okay, so we already have the 1 for our tangent. Our adjacent will be that 3.9. Okay, now that we've done 2, any questions on, like, how did you get that? Why did you write that there? How did you know that? Okay. So all I'm going to do here is write the steps down. So if you can listen to the steps and memorize them. Step number 1, you're going to draw your reference triangle. Some of you like steps. And label it. I would also label your numerator and denominator. Maybe even before that, I don't know. Oh my gosh. I hope they won something good. When I say numerator and denominator, I mean these ones, and I would label these ones. I would label both sets. Because maybe you have everything you need, you just need to switch them, right? You might not even need to do the Pythagorean theorem. Like if it gives you cosine and secant, which it didn't. So cosine is adjacent and hypotenuse. Cosecant is hypotenuse and opposite, so we will need to do the Pythagorean theorem. The third thing, if you need to, Pythagorean theorem. Okay, let me make sure that gets us ready for the whole front. Yeah. Is anyone writing the steps down? I always liked steps. They were my favorite. I was like, if you would just tell me what to do, I could do it. Anyone else feel that way? Like, I don't know what to do next. Okay, obviously the last thing is then plug in any of those numbers into what they're asking for. Okay. The back of the worksheet looks like this. So it starts out the same. Label your numerator and denominator. So where did I get to in calling on people? I got to Ellie. For sine, what do I label the 3 and the 5 as far as adjacent, opposites, and hypotenuses? And actually, let me pause. Do this one in your notes, because we're just doing the one, I think. So write this one down. Given sine of theta is 3/5, find 2 times sine squared of theta plus 3 times cosine theta. All right, step number 1, label. Draw our picture here. Here's my opposite, hypotenuse. Jaden, do you have this Pythagorean triple memorized? If you don't have it memorized, you can do the Pythagorean theorem again. 3, 4, 5 is used a lot. So some of us will remember that one. Okay. What is the sine of theta? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. So once we do this, we just start with the equation. 2. Instead of writing sine of theta, we're going to find it. So opposite over hypotenuse. And then it has this to the power of 2. So we're replacing it with the fraction. Like very first day, all we did was write those fractions, write the fractions, write the fractions. So this is taking us back and applying that. And then our plus sign. Now we put the cosine of theta, which is adjacent over hypotenuse. You can just plug that into your calculator. I really want to know what they're doing over there. What did you guys get? 78.12? I don't know. It would be hard to correct. When you pushed enter, yours gave you a fraction? 78 over what? You can just type in 78 divided by 25. See if that punches it out. Okay. Yes, Andrew. I told you I don't like this lesson. I don't know. This is advanced trig. You guys should write an essay on when you use this in your life, so I don't have to answer. I can just read your essays. Okay, so the steps, when you see these, the steps are similar to before. So I'm just going to leave these on the board. You're going to want to label all these fractions. Tangent is opposite over adjacent. Sine, opposite over, write these in at the beginning. Cotangent, because they're just really simple numbers. As long as you write them in, these are very simple numbers. So label your numerators and denominators. If you're wondering why this changes colors, I don't know why. Is it a negative what? Draw your reference triangle. Solve for your third side. And then plug those numbers back where they need to be. So we're going to plug opposite, adjacent, and hypotenuse into your equation. So I can leave this up here so you can be looking at it. Raise your hand if you want me to do this one. Such enthusiasm. I will come help you with your first one on your paper. Okay. Uh-huh. I'm going to assign the odds only. If you are so speedy that you're done with those very quickly, you can challenge yourself and do a few extra ones. Edwin, did you fall asleep on me?